Hello, everybody. In this activity, we're going to start talking about something called proof. Now, what you've been looking at two triangles and determining what method of triangle congruence is appropriate for these two triangles. So, for example, this one is straight from the quizzes that you guys just did. And as you can look at it, let me make this full screen right here. As you look at it, you're seeing, okay, a side, and a side. This is a side, and a side. So I know that out of my options here, just so we have it, side, angle, side, angle, and then our HL, which is really for only for right triangles here. So we have these five options. This one, the one right in this picture, uses only sides. There's only one right here. So side, right here. Now, what we're doing in this activity is we are going to see how mathematicians would prove these two triangles are congruent beyond a shadow of a doubt here. And we're going to do that by showing it in a version 1 in an organized list, and then below in a flowchart. This handout is in Canvas, so if you can print it out and follow along. If you can't print it out, just do it on your own paper along with me here, okay? So for the organized list, we realized that to prove two triangles are congruent using side, we have three pieces of evidence here. Three pieces of evidence. And depending, it might be easy for you to see, it might not, but the three pieces of evidence are our side, and side right here. So we know that we'll just choose one. So for the first evidence right here, we'll do a side. So which one? Let's do the 1-1. So these guys are congruent. A, B, we'll write that with our sign for a side right up here, is congruent. That's our congruent sign. To now A is the letter between the 2 and the 1 dash. So how I think about this is I want to start with the same corresponding letter in this triangle. So the letter between the 2 and the 1 dash is E. So AB is congruent to side E and then F right here. And how do we know this? Did this come from an alien? Did this information come from some other way? No, it was given to us. So this reason right here is going to be that it was given to us in the diagram. It was given here, okay? The next piece of evidence could be another side right here. We did the 1 dash. Let's do the 2 dashes now. So the 2 dash right here, I have AC. AC, side AC is congruent to, now the corresponding letter to A is again E, so E, but instead of F, E, D right here, ED. And again, this was given to us in the diagram. And our third piece of evidence right here is another side. And we did the 1, we did the 2, let's do the 3 dashes now. I'm gonna start with CB here, okay? So side CB is congruent to side. Now let's see. C is in between the 2 dash and the 3 dash right here. In between the 2 dash and the 3 dash, I see a D right here. So D is the corresponding point. So DF. Side DF is congruent to side CB. And why is this true? Again, this is true because it's literally given to us in our diagram right here. That won't always be the case here. Another given. One version done. Well done, everyone. Now, how do we put this onto a flowchart? We like flowcharts for lots of reasons. One of them being that it kind of shows the flow of logic a little bit better. So you might be able to see where this is heading, but these three bubbles are for our three pieces of evidence. And inside the bubble goes our claim of the evidence, our evidence right here. So for the first one, we'll put AB is congruent to EF. And where do we put the reason right here? The reason goes right underneath our bubble. So this given is going to go right underneath the bubble right here. This is a given statement. It was given in our diagram. And where does the side go? This might be something that Mr. Schnock and I do differently, but I'm going to put the side or angle thing right here so I know side. Okay. The second thing here is AC is congruent to ED, and that here is a given as well. And again, this is another side. And our third piece is CB, side CB is congruent to side DF. That is also given. That's our third side. So we're now ready to make a statement. We're now ready to be kind of powerful in this moment. We have enough information to say for sure that triangle, and I've given you the triangle sign right here, triangle. Let's see, I want to do ABC right here. Triangle ABC is congruent to, all right, corresponding point of A was E. So it would be incorrect for me to say triangle ABC is congruent to triangle DEF because A and D, they are not corresponding points. A and E are. So triangle ABC is congruent to triangle E. And then what point is corresponding to B? B is in between the 1 and 3, so that would be F right here. E, F, D. And that's our major claim right here that we have proven that these two triangles are congruent. Our congruency reason is the side, side, side. I like to do this with some shortcuts, triangle congruence method. Okay? And our proof conclusion, what did we just do? What was your initial claim? Therefore, because this evidence satisfies the requirements for side, side, side congruency, I know that triangle ABC is congruent to triangle EFD. Now, folks, pause. Ooh, I didn't let you see that. My apologies. Pause right here and see if you have any questions. Ask someone in the same breakout room, ask someone around you, text somebody, ask your teacher. See if you have any questions about this first proof. Pause it, please. And if you're coming back, let's try the next one together, which might be a bit more interesting here, okay? Now, 2, we have a triangle again from your quizzes. I don't know if you remember this one. And we're really only given 2 pieces. That side BA is congruent to side ED, side BA is congruent to side ED, and angle A is congruent to angle D. So I see a bit of a rotation going on here. Now, but we do know something about these 2 angles right here. These 2 angles, I think they're part of our angle vocabulary. It starts with a V. These 2 angles are vertical angles. I'm going to mark them congruent by putting the same 2 dashes in their angle arc here, okay? Now, this was because, I'm just going to put a little note right here. Those vertical angles. And we'll say more about that in 1 second here, okay? Let's do this. So let's first get our congruency conjecture or method right here. If you don't like the word conjecture, we can think about this as a method here, okay? Congruency method. Let's see, I have 2 angles and then a side. So I have 2 angles on a side, and here's my question. Is this side in between these 2 angles? And I think you can say, no, this side is not in between. This is a side angle angle, and this also is a side angle angle. So I'm dealing with a side angle angle. And is that one of my good ones, the ones that works? Yes, it is. So that will prove that these 2 triangles are congruent. Let's do our organized list, everybody. I want to start with the side here, okay? And my evidence here, okay, I'm going to go A side AB is congruent to, wait, don't just do ED. I have to figure out what point, what vertice, what letter is corresponding to A. And I already know that angle A is congruent to angle D, so I know that A and D are corresponding here, okay? So side AB is congruent to side DE. My reason? Well, this was given in our diagram. So I have a good old-fashioned given reason right here. Let's go to our second piece of evidence. I'll do an angle here. I'm going to do angle BAC. I'm using the 3-letter name right here. So angle BAC is congruent to angle, okay, BAC. What point is corresponding to B? That's E right here. So E, of course I ran out of space, EDC. Okay? And our reason for this, again, this was given in our diagram. We have a given right here. It won't always be given, but it has been so far. But let's take this last angle right here. Our last angle. This is angle BCA. angle BCA is congruent to, okay, BCA, corresponding point to B is E, so ECD. Angle ECD. All right, and people, this was not given. This is the big idea. This is not a given reason right here. What was given to us was that these were vertical angles. So the reason that we can agree on here is by definition of vertical angles here, okay? Vertical angles. So by the definition of vertical angles, we know that these two angles are congruent. So that was our first non-given reason right here. So that could be a little bit challenging to understand. You'll have more practice with that later. Now let's see if we can go about this. Now, I'm gonna have to add a bubble here, but I'll show you that in 1 second. Let's start with our side evidence and given reason right here. Let's go with this one. So AB is congruent to DE, and that here is a given statement. That's a side. And our angle BAC is congruent to angle EDC. That was given. Okay, and this was an angle. Now here's what I'm gonna do. I'm gonna add a fourth bubble because we need something above this one right here. Let's first figure out what this one's gonna say. This one's gonna say our last one. Angle BCA is congruent to angle ECD. This one is not given. This is by the definition, and I'm gonna shorten this definition of vertical angles. But before we can use the definition of vertical angles, we have to know that they are vertical angles. So here's what we're going to do. We're going to add a bubble right here. And here's what the picture gave us. The picture gave us that angle BCA and angle ECD are, oh dear, vertical angles. That is what was given, is that these guys are vertical angles right here, are vertical angles. So this is what was given in our diagram. And from this, we could say, okay, if they are vertical angles, then they are congruent. That right there is something that I would ask a teammate about. I would ask my teacher about if I didn't understand, okay? Now, all this being said, we now have enough for our claim right here. Let's write our, okay, triangle sign. I'm gonna start with A over here. Triangle ABC. So ABC is congruent to triangle. Okay, corresponding point to A is D. So triangle D, and then across to E, C. C is used in both. And our congruency reason is side, angle, angle, triangle, congruence method. Okay. Therefore, because this evidence satisfies requirements for side angle angle congruency, I know that triangle ABC is congruent to triangle DEC here, okay? You're gonna be getting more practice with this in 1 second, and actually I wanna show you where that's going to be. Follow my screen here. You're gonna get a link soon to something that looks like this. When you get to this, I want you to read the instructions. I want you to have the instructions read to you by me. And then I want you to start figuring out, okay, for this one, I need to drag pieces of this into the organize this where they belong. So for this last one, will it be a side or an angle right here? I'll let you decide that, okay? After you're done with this page, you'll then go on to the second page. And if my internet works, then you'll go on after you're done with the second page to the third page. And I want to show you this because the third page is the same thing as the rest of the handout that we were just working on. So you'll find this on the rest of the handout that we did this work on right here. Thank you very much, everybody.